In 1970, a team of Soviet engineers began drilling a hole into the earth, unaware that the deepest layers held temperatures and isolation that would break their minds. This is MrPhantom, and tonight we are going underground, deeper than any human being has ever physically gone, deeper than any drill in history has ever reached. We are going to the Kola Superdeep Borehole, a Soviet project that ran for 24 years, defied every scientific prediction ever made about the Earth's interior, and left a welded metal cap in the ground in northwestern Russia as the only monument to one of the most extraordinary and punishing scientific endeavors in human history. This story has no supernatural elements. It needs none. The real story is disturbing enough on its own terms, because what the Soviet scientists found when they drilled deeper than anyone had ever drilled before was not what any of them expected, and what the project cost in time, in money, in human endurance, in scientific certainty, in the psychological toll on the people who gave years of their lives to a hole in the ground in one of the most remote and hostile environments on Earth was more than anyone had calculated when the drilling began. Let us start with context. Because the Kola Superdeep Borehole did not begin as a scientific project in isolation, it began as a competition, and understanding the competition is essential to understanding why the Soviet Union was willing to commit the resources it committed and push the project as far as it pushed it. The 1960s were the height of the space race. The United States and the Soviet Union were competing in every domain of scientific and technological achievement that could be framed as a proxy for national superiority. Space was the most visible arena, but it was not the only one. In scientific circles, another race was quietly underway, not upward, downward, into the Earth itself. The concept had a name, the Mohole Project. In the late 1950s and early 1960s, American scientists proposed drilling through the oceanic crust to reach the Mohorovičić discontinuity, the boundary between the Earth's crust and the mantle beneath it. The Moho, as it was informally called, represented a fundamental geological boundary that science had never directly sampled. Reaching it, bringing up actual mantle material for study, would be one of the most significant geological achievements in history. The Americans drilled test holes in the Pacific Ocean floor in 1961. The ocean floor was chosen because the crust is significantly thinner under the ocean than under the continents, making the Moho more accessible. The early tests were promising. The project attracted serious funding and serious scientific attention, and the Soviets noticed. The Soviet response was characteristic of Cold War scientific competition. If the Americans were going to drill to the Moho through the ocean floor, the Soviets would drill to the Moho through the continental crust. It would be harder. It would require going much deeper. It would be technically more demanding, but it would be done on Soviet territory, under Soviet control, producing Soviet scientific results. And if they got there first or got deeper, it would be another demonstration of Soviet scientific capability to the world. Project Moholo, the American effort, was cancelled by the United States Congress in 1966, killed by cost overruns and political disputes. The Soviets did not cancel their project, they accelerated it. In 1970, on the Kola Peninsula in the far northwestern corner of Russia, above the Arctic Circle, in a landscape of tundra and granite and long polar winters, Soviet engineers began drilling. The location was chosen deliberately. The Kola Peninsula is part of the Baltic Shield, one of the oldest and most geologically stable continental rock formations on Earth. The rocks here are ancient, some of the oldest surface rocks anywhere in the world, formed billions of years ago. Drilling into the Baltic Shield would give Soviet scientists access to rock that had not been touched since the earliest periods of Earth's geological history. The scientific value was immense. The practical conditions were something else entirely. The Kola Peninsula in winter is one of the most hostile environments in the inhabited world. Temperatures drop well below -30 degrees Celsius. Polar night, the period when the sun does not rise above the horizon at all, lasts for weeks. The landscape is flat, dark, windswept, and almost entirely empty of human habitation across vast distances. Getting equipment, materials, and personnel to the drilling site required sustained logistical effort. Keeping them there, functional and productive, required more. The drilling operation was a major industrial installation, not a small research station, a significant facility with specialized equipment designed specifically for this project, because no existing drilling technology was capable of going where the Soviets intended to go. Standard oil and gas drilling equipment was built to operate at depths of a few kilometers at most. The Kola project was planning to go to depths of 10 kilometers kilometers or more, into rock conditions that no drill had ever encountered, at temperatures that no equipment had ever been tested against. The Soviets developed a new drilling technique for the project. Rather than rotating the entire drill string from the surface, which becomes mechanically impractical at extreme depths because of the enormous weight and torque involved, they used a system where a turbine at the bottom of the drill string was powered by drilling fluid pumped down from the surface. The turbine rotated the drill bit itself while the drill string remained stationary. This was called turbo drill technology, and it was a genuine Soviet engineering innovation that allowed drilling to continue at depths where conventional rotary drilling would have been impossible. Even with this technology, progress was slow, measured in meters per day, sometimes meters per week, as depth increased and conditions became more difficult. Drilling began in 1970. By 1979, 9 years into the project, the borehole had reached a depth of approximately 9,500 meters. This broke the existing world record for the deepest borehole ever drilled, previously held by an American oil well in Oklahoma called the Bertha Rogers Hole, which had reached 9,583 meters in 1974. The Kola project pushed past that and kept going. The world record was noted in Soviet scientific literature with appropriate satisfaction, and the drilling continued. By 1983, the borehole had reached 12,000 meters, 12 kilometers into the earth, nearly 40,000 feet, a depth that exceeded the height of Mount Everest by several kilometers, a depth that no human instrument had ever reached inside the continental crust. And that is when the problems became severe enough that drilling had to stop entirely for a period. The problems were not mechanical failures in the conventional sense. They were failures of prediction, failures of the scientific models that the entire project had been built upon. Because what the Soviet scientists found at depth was not what their models told them they would find, not even close. The first prediction that failed was temperature. Before drilling began, Soviet scientists had models for how temperature would increase with depth inside the Baltic Shield. These models, based on the best geological understanding available at the time, predicted that temperatures at 12 kilometers would be approximately 100 degrees Celsius, roughly the boiling point of water at surface pressure, manageable, within the range that engineered materials could handle. The actual temperature at 12 kilometers was approximately 180 degrees Celsius, nearly double the prediction. This was not a minor discrepancy. This was not an error within the margin of acceptable variation. This was a fundamental failure of the geological models that Soviet scientists had used to plan the entire project. The Earth at depth was far hotter than they had calculated, and that heat had consequences that cascaded through every other aspect of the operation. At 180 degrees Celsius, the rock behaves differently than at 100 degrees, differently than any temperature Soviet engineers had designed their equipment to handle. Rock that their models predicted would be hard and brittle at depth was instead behaving in a semi-plastic way, deforming slowly under pressure rather than fracturing cleanly. This was not rock that a drill bit could bite into and remove efficiently. This was rock that was, in geological terms, flowing very slowly around the borehole, partially closing the hole behind the drill as it advanced. Drill bits, which are the cutting tools at the bottom of the drill string, are consumable items in any drilling operation. They wear out and need replacement. But at the temperatures and under the conditions at the bottom of the Kola borehole, drill bits were being destroyed at rates that were economically and logistically brutal. Each bit had to be retrieved from the bottom of the hole, which required pulling the entire drill string, kilometer by kilometer, back to the surface. At 12 kilometers depth, that retrieval operation took days, and then the new bit had to be lowered back to the bottom, which took more days. The time spent not drilling, just managing the equipment, was enormous. Beyond the drill bits, the drilling fluid itself was behaving unexpectedly. Drilling fluid is pumped down the borehole to cool the drill bit, carry rock cuttings back to the surface, and maintain pressure in the hole to prevent collapse. At extreme depth and temperature, the fluid's properties changed. Its viscosity, its chemical stability, its ability to perform its essential functions, all of these were affected by conditions that the fluid's designers had not anticipated. The borehole itself was not a clean, straight cylinder. It wandered. Despite every effort at directional control, the drill deviated from vertical as it moved through rock of varying hardness and density. At some points, sections of the borehole wall fractured and collapsed partially, creating zones of instability that required careful management to keep the hole open. The deeper the drilling went, the more complex and unpredictable the underground environment became. In 1984, following the period of operational difficulties around 12 kilometers, drilling resumed. Progress was slower than ever. The conditions were more difficult than ever, but the project continued, and the scientific data coming back from the depths was extraordinary. Geologists had expected, based on seismic wave analysis of the Earth's interior, to encounter a boundary at a certain depth where one type of rock transitioned to another. Seismic surveys of the Baltic Shield had suggested that at around 7 kilometers, the characteristics of the rock would change from granite-type rocks to basalt-type rocks. This transition had been predicted with considerable confidence. Seismic wave behavior, the way earthquake waves travel through rock, had strongly suggested this boundary existed. When the drill reached 7 kilometers, no such boundary was found. The rock continued to be granite, different granite than the near-surface rock, altered and transformed by pressure and heat, but granite nonetheless. The predicted basalt layer did not exist. The seismic data had not been wrong exactly, but what it indicated was not a rock-type boundary. It was a metamorphic boundary, a zone where the same type of rock had been transformed by heat and pressure into a different form that behaved differently under seismic analysis, but was chemically and mineralogically the same material. This was a significant scientific discovery. The seismic interpretation that geologists had relied upon for decades to understand the deep crust, not just at Kola but globally, had to be revised. The Earth's interior was not structured the way the best available science had predicted. More followed. At depth, in rocks that by every geological calculation should have been completely dry, having been under enormous pressure for hundreds of millions of years, the scientists found water. Not a small amount, significant quantities of water, described by scientists on the project as fractured rock, saturated with water that had migrated from the surface over geological time. The water was mineral-rich, altered by billions of years of contact with deep rock chemistry, but it was water. In rock where, according to existing models, no water should have been able to survive. The presence of water at that depth had implications for understanding geological processes, for understanding how minerals form, for understanding how the deep crust behaves over geological time. It was genuine and significant scientific discovery. And then there was the biological discovery. In rock samples brought up from depths of 6 to 7 kilometers, rocks that had been sealed away from the surface for hundreds of millions of years, scientists found microscopic fossils, single-celled organisms, 24 distinct previously identified species of ancient single-celled life preserved in the rock for geological ages. Life had existed at some point in the deep past in conditions and at depths that no one had previously considered habitable. These findings were published. They contributed to the scientific literature on deep geology, deep biology, and the structure of the continental crust. The Kola Superdeep Borehole produced genuine scientific knowledge that advanced human understanding in multiple fields. This is important to acknowledge clearly because the project was not simply a monument to Cold War competition and human stubbornness. The science was real and it mattered. But let us talk about the human dimension. The drilling facility on the Kola Peninsula operated continuously for 24 years. It was not a temporary field station. It was a permanent industrial and scientific installation with permanent staff, rotating crews, and all the infrastructure required to keep people alive and functional in an Arctic environment while conducting one of the most technically demanding engineering operations ever attempted. The workers and scientists who staffed the Kola project were not volunteers who signed up for short tours and returned to comfortable urban lives. Many of them spent years at the site. The Kola Peninsula is genuinely remote, and while the Soviet state provided accommodation and facilities, the isolation was real and continuous. The nearest significant city was Murmansk, roughly 100 kilometers to the northeast, itself not a place of great comfort or accessibility in the Soviet era. Polar winter on the Kola Peninsula is not a brief inconvenience. It is a weeks-long period of darkness, cold, and enforced confinement that has documented psychological effects on populations that live through it. Research on Arctic and Antarctic workers has consistently shown elevated rates of depression, anxiety, sleep disruption, and cognitive effects associated with prolonged isolation, darkness, and the particular psychological stress of operating in environments that are fundamentally fundamentally hostile to human presence. The workers at Kola were exposed to all of these conditions for extended periods. The project was classified. Workers were not free to discuss their findings or their experiences outside the installation. This is a form of psychological isolation that compounds the physical isolation of the location. When you cannot speak freely about what you are doing, when the work that defines your daily existence must be kept secret from family and friends outside the facility, it creates a particular kind of mental pressure, not dramatic, not cinematic, but cumulative, grinding, and real. The nature of the work itself had a psychological dimension that is easy to underestimate. These scientists and engineers were working at the frontier of human knowledge, literally, physically, in the most direct sense possible. Every meter of depth they achieved was a meter further than any human instrument had ever reached inside the Earth, and every meter was telling them that the Earth was not what they thought it was, that the models they had trained on, the geological understanding they had spent careers developing, was incomplete in fundamental ways. There is a particular kind of intellectual disorientation that comes from having your foundational assumptions repeatedly contradicted by evidence. Scientists are trained to follow evidence, to revise beliefs when evidence demands it. But when the revisions are this large, when the gap between prediction and reality is this consistent and this significant, it creates a form of cognitive strain that is qualitatively different from ordinary scientific revision. The deeper the Kola drill went, the less reliable all prior geological knowledge seemed. They were not discovering that they were wrong about minor details. They were discovering that they were wrong about major structural features of the Earth's crust, that the boundary layers identified from the surface did not exist as identified, that the temperatures were wrong, that the rock behavior was wrong, that water existed where no water should have been, that ancient life had survived in places no one thought life could survive. Every discovery was genuinely exciting from a scientific standpoint, and every discovery was also a reminder that the Earth, even the crust, the outermost and most accessible layer of the planet, was far less understood than the scientific establishment had believed. In 1992, the borehole reached its final depth of 12,262 meters. The drilling did not stop because the project had reached its scientific goals. It did not stop because the team had decided they had gone far enough. It stopped because the conditions at that depth had defeated the available technology. At 12,262 meters, the temperature was approximately 180 degrees Celsius, and the rock was behaving in ways that made further drilling effectively impossible with the equipment and techniques available. The rock was plastic. The hole was unstable. Drill bits were being destroyed faster than they could be replaced practically. The engineers tried. They attempted new approaches, new bit designs, new drilling fluid formulations. Progress slowed to effectively zero. And then, in 1994, as the Soviet Union that had conceived and funded the project had already collapsed 3 years earlier, and as the Russian Federation that inherited it was in deep economic crisis with no resources to spare for expensive scientific projects of uncertain immediate value, the Kola Superdeep Borehole project was officially terminated. The installation was decommissioned. The equipment was removed or abandoned. The borehole itself was capped. A welded metal cap was placed over the top of the hole, which is itself only approximately 23 centimeters in diameter, slightly less than the width of a dinner plate, despite being 12 kilometers deep. The facility sits on the Kola Peninsula today in a state of significant decay. Buildings that once housed scientists and engineers and the administrative infrastructure of a major, classified Soviet project are empty and deteriorating. Equipment that was not removed after decommissioning has rusted and collapsed. The Arctic weather and the passage of years have done what they always do to structures that are no longer maintained. The site looks like many abandoned Soviet industrial installations, which is to say, it looks like a place where something significant happened. In the past, before the significance ran out, the metal cap on the borehole is unremarkable to look at. A disc of welded steel bolted to a concrete collar sitting on a patch of ground that looks like every other patch of ground on the Kola Peninsula. Nothing about it from the surface indicates what it covers. Nothing marks the 12 kilometers of empty hole descending straight into rock that is older than most life on Earth, into temperatures that would kill a human being in seconds, into pressures that would crush any existing submarine, into geology that confounded the best scientific minds of a superpower that no longer exists. The Kola Superdeep Borehole remains the deepest hole ever drilled by human beings. No project since has equaled its depth. Various proposals to drill deeper, to restart the race to the moho that began in the 1960s have been discussed in scientific scientific circles. Modern drilling technology has advanced significantly since 1994. Some projects have reached depths approaching Kola's record in offshore ocean floor drilling, which remains the more practically accessible route to the Moho because the crust is thinner there. But no human-directed drill has gone deeper into the continental crust than the Soviets went on the Kola Peninsula between 1970 and 1992. The Earth kept its deeper secrets, not because it was protecting them. The Earth does not protect or conceal anything. It simply is what it is, indifferent to human curiosity, indifferent to human technology, indifferent to the 24 years of effort and the careers and the isolation and the replaced drill bits and the revised geological models and the welded metal cap. The scientists who worked at Kola made real discoveries. They advanced human knowledge in ways that are documented in the scientific literature and that continue to inform geological research today. The finding that deep crustal temperatures were far higher than predicted has been integrated into geological models. The discovery of water at depth has influenced understanding of deep geological processes. The revision of seismic interpretation methods following the discovery that the predicted basalt layer did not exist has had lasting effects on how geologists read seismic data from the deep crust. The project was not a failure, but it also did not achieve its original stated goal. The Mohorovičić discontinuity, the boundary between crust and mantle that the entire race had been organized around reaching, was never touched. At 12,262 meters, the Kola borehole was still, by geological estimates, roughly a third of the way through the continental crust at that location. The Moho at Kola lies at an estimated depth of approximately 35 kilometers. The drill stopped at 12. The remaining 23 kilometers might as well be on another planet. The Earth is large, incomprehensibly, practically large, even in the sense of what lies directly beneath your feet. The deepest any human tool has ever gone is 12 kilometers. The distance to the center of the Earth is over 6,000 kilometers. We have barely scratched the surface, literally, in the most literal sense of the phrase. And the hole in the ground on the Kola Peninsula, sealed under a welded cap in a decaying facility in the Arctic, is the furthest we have ever reached. The monument to the furthest human beings have ever gone downward. 12 kilometers of empty shaft, descending into heat and pressure and geology that defeated the best engineering of a superpower that no longer exists. That is the story. Not supernatural, not invented. Every number real, every discovery documented, every difficulty genuine. The Soviet scientists who drilled too deep did not find hell. They found something in some ways more unsettling. They found that the Earth, the ground beneath every human civilization that has ever existed, is far less understood than the humans who live on its surface have ever fully accepted. They found that the models we build to explain the world beneath us are incomplete in fundamental ways that only direct evidence can reveal. And they found that getting that direct evidence costs more than almost anyone is willing to pay for very long. The cap is still there. The hole is still there. 12 kilometers deep, sealed, silent, going nowhere. Thank you for watching, Mr. Phantom. If this story disturbed you in the way that only real things can disturb you, subscribe so you do not miss what comes next. Like this video if the Kola Superdeep Borehole stayed with you. And the next video on your screen right now is a story about another project. Another group of people who pushed past the limits of what was known and paid a price that no one who planned the project had calculated. Every fact verified, every detail real. Mr. Phantom, true stories only.